So now in this video we're going to look at parallel resistors for providing more current, in this case to an LED, but it'll work anytime you need more current than a single resistor can provide. So we'll look at that in a little bit. In any case, if we have 12 volts and we have an LED with a forward voltage of about 2 volts right there, that means there's going to be about 10 volts across the resistor and 10 milliamps of current flowing through it. Up here I showed the math, so we have 12 volts from the supply minus 2 volts forward voltage of a LED in this case. That gives us 10 volts that goes across the resistor, which ends up setting the current at that point. 10 volts divided by 1,000 ohms, a kilo ohm is 1,000 ohms, gives you 0.01 amps. Remember, you got to do the math in amps, but that's the same as 10 milliamps right there. So here is the thing. We already saw we got 10 volts across the resistor and then 10 milliamps of current flowing through it, 0.01 amps. You multiply those together, you get 0.1 watts. So most resistors are quarter watt, 0.25, but you still keep them below 0.125. And as you can see right there, this is pretty close to 0.125. So we don't want to use a lower value resistor. It will get hotter to get more current. What we can do is just wire a couple in parallel. And so here's the parallel circuit in more detail. So we got 12 volts. The LED, if it's red, it's going to drop about 2 volts. If it's green or blue, it's going to drop about 3. But we're just going to keep this simple and assume a red or similar color LED that drops about 2 volts. So the 10 volts now is across each one of the resistors independently. And so this one's going to pass about 10 milliamps of current, as is that one. They're both going to pass about 10 milliamps of current, and we're going to have 20 milliamps total. But they won't get any hotter than this one by itself right there. So we will not exceed their recommended wattage rating. And so here we are on the breadboard. I have power set to 12 volts right there with a maximum of 25 milliamps because we're aiming for 20 milliamps. We want to make sure that it doesn't cut off because that was the limit that we set. But in case, there we have about 8 milliamps. You can see the green LED is really bright with 8 milliamps, so we'd be happy with that for the most part. We could add another resistor, and we'll zoom in a little bit, but we could add another resistor. You see it gets brighter and current goes up. So now it says about 17, so it's probably actually closer to 18, and there it's probably, there we can see 9 right there. So this isn't completely accurate, but it's still relatively close. So we will pop out the LED there and look at the red LED quick, and there you can see we got about 9 milliamps of current, and I'll zoom in so that you can see me adding the other resistor. So there's the LED, that's the long lead anode, short lead the cathode there. Remember, you got to put it in the right way for it to light up, and when I add the other one, you'll see it get brighter. So the red LED, even though it has less current, is even more current, I mean, than the green LED. You can see it's not as bright. So we add the other resistor here in parallel, and there you can see it got brighter, and there you can see we hit that 20 milliamps of current, even according to this, which is usually kind of off about 1. So in any case, that's really about it. That's one use. These resistors are not going to get any hotter than the one by themselves, but we have twice the current, and it's an equivalent of half of the resistance too. It's like a 500 ohm resistor, a single one, instead of 2 1 kilo ohm resistors. But it is 2 1 kilo ohm resistors in parallel. So, hope you enjoyed the video. Make sure you check out one of the other ones I'm posting. Click like, subscribe, the bell, all that. Donate to Patreon if you can. That helps out the most. I have a link down in the description. But just watch as many videos as you can. Helps out a ton. Thanks for that. I'll see ya in the next video.